Hi everyone, welcome to this new video lecture of fluid mechanics. In this lecture, we'll discuss some problem related to Pascal's law. In our previous video lecture, we have discussed the theory and derivation part of Pascal's law. So let's discuss some problem related to Pascal's law. Here I have taken a question. A hydraulic press has a ram 30 centimeter diameter and a plunger of 4.5 centimeter diameter. And we need to calculate what the weight lifted by the hydraulic press when the force applied at the plunger is 500 Newton. Okay. So this question is given in such a way that suppose there is a construction of this hydraulic chamber is like this, and here one ram side is there. Suppose this is ram side and another side is plunger side is there, and here the weight is supposed to going to raised by the this is the suppose ram side, and where the diameter is given 30 centimeter, and this is plunger side, and here there is a weight, or you can say the force applied here, that is 500 Newton. Okay, and this is write down, this is plunger and this is ram, and here diameter is less 4.5 centimeter, and we need to calculate the weight lifted by the hydraulic press. Okay, weight lifted by the hydraulic press. So let's solve this one now. So here let's see diameter D is given, that is 4.5 centimeter, that is for the plunger side. So area also you can calculate here, pi by 4 d square, and so here pi by 4 into d 4.5 into 4.5, or we can convert into meter also. Okay, so here we'll get the value near about, let me check it once, or you can convert into meter, that will be 0.045 meter. Okay, so how much will be there? 3.14 into 0.045 into 0.045 equal to divided by 4, 0.00159. So that is 0.00159 meter square. Okay, this is the area at the plunger side. Similarly, here the ram is given, so this one I can consider capital D. So capital D given 30 centimeter, so that one we can write 30 centimeter, we can convert it into 0.3 meter, and area, capital area, we can write capital A pi by 4 d square. So similarly we can write pi by 4 into 0.3 into 0.3. Okay, and now this one we can solve it, we can identify the value here again. So again 3.14 into 0.3 into 0.3 divided by 4, 0.07065. So 0.07065 meter square. Okay, this is the area at the ram side. Now the question given, what is the weight lifted by the hydraulic press when the force is applied here at the plunger side? So due to this force, how much load is going to raised by this, or how much weight is going to lifted by this impact of force, that need to calculate. So let's first calculate here what the pressure is applying here at the plunger side. So we can write P equal to, we know that force by area. So here how much is there? P equal to, we can say 500 divided by this area, how much? 0.00159. so that will be near about 500 divided by 0.00159. so 3,14,465, 314,465 point, some value is there, 41 will write 41, this is Newton per meter square. Okay, that much pressure is there. So similarly, we know that as per the Pascal's law, what is the pressure applied at one point, the same pressure is going to release by the all the sides, all the points. Okay, so here in the ram side also you can write the pressure at the ram side. This is at the plunger side. Okay, so pressure at the ram side is equal to, we can write the force or the weight lifted. Here a force not required because here already force applied. So you can write how much weight is going to raised by this. So weight by area. You can write here weight by area. So we require the question here, how much weight lifted here. So we can write W equal to P plunger, what we got, same equal to P ram. So you can write P ram into the area at this point. Okay, so this is actually small area here, and here it is capital area. Okay, so what I got here, 31465.4 into area, how much is there, 0.07065. so let's check it once. This multiply 0.07065, how much will be there, 22201. okay, 22201, this is Newton, or equal to, you can write 22.210 kilonewton. So that much weight is going to lifted at this point due to the impact of force which is applied at the other end. Okay, so this is the answer. Okay, let's solve one more problem in this Pascal's law. So the question is given, the diameter of a small piston and large piston of hydraulic jacks are 3 cm and 10 cm respectively. The force of 80 Newton is applied on the small piston. Find the load lifted by the large piston. Conditions given. First condition is the pistons are at the same level. Second one is the small pistons in 40 cm above the large piston, and the density of the liquid is given, jack is given 1000 kg per meter cube. So let's write down the data given first here. Okay, let's draw one diagram for this. Here two diagrams need to be drawn. One is for condition 1, another one is for condition 2. So first let condition 1, so diagram will be like this, this is one, a large piston is there, okay, and another one, small piston will be connected to this. Let connect like this, and here this is the piston, the small piston is there, both should be in the same level, actually little bit difference is there, and here the hydraulic oil will be there in this, suppose. Okay, now this is large piston side where the diameter is 10 centimeter. This is capital A, we can say, and this is capital D. This is capital D diameter, so that we can calculate the capital A pi by 4 d square. Similarly, here also the small d given, that is 3 centimeter, and here we can calculate the small a pi by 4 d square. Okay, similar method we can calculate. Now what is the given next? A force 80 Newton is applied on the small piston. So this is the small piston is there. So here one force will be applied here. Let's give the remark here like this. Force, how much is there? 80 Newton. Okay, and what is the load is going to lifted by this due to this force? Okay, that need to be calculated. So previously how we have done the problem, similar way here also you can solve it. So again we need to calculate the value of A, as I told you here, pi by 4 d square. So that will be near about 78 point. Okay, let keep the same centimeter, no need to change into meter. Let keep it in the same way. So we'll get pi by 4 3.14. so that will be 3.14 into 100 divided by 4, 78.5. so that is near about 78.5 meters square. Similarly, small a equal to, again we can write 3 by pi by 4 d square. D square means 9 into 3.14, 27 by 4. So it is near about 7 point something will come, that is meter square. Okay, this is the area of the large piston and small piston. Now we need to find the load lifted by the large piston when a load lifted by the large piston. Okay, here one, let's see, load symbol is there, W is there. Okay, load lifted when the piston is at the same level, both pistons are same level, and the force applied here 80 Newton, and we need to calculate the load. Similar method what I done there, same thing we can calculate again. We can do here P equal to F by A. So here F equal to 80 Newton and area equal to, you can say 7 here. So we can got the value of pressure here at this point. Now as per the Pascal's law, we know that same intensity of pressure which is applied here, that will be equally distributed to other directions also. So here we can write pressure, okay, at the small piston side. Similarly, the pressure at the large piston side also will be same, and here also we can write what is the load lifted is at this side, force or W we can write divided by A. So we can write what is the force or what is the weight load lifted at this other side. That means the pressure what we got here 80 by 7 into this area will be there, how much, 78.5. so let's solve this. 78.5 into 80 divided by 7, so 897, that will be there 8. So how much load is going to lifted here, 897, near about this amount is coming. I have taken approximately 890, near about you can consider this one. Okay, now this is one condition. Second condition is given what, now when the piston, small piston is, another one diagram we need to done. So let's consider another one diagram for this. This is the here it is like this. Okay, now this is our normal piston is there here. Okay, and here another piston is with a gap of, with a height of 40 centimeter from here. Okay, now here also this same force is applied here. Okay, and due to this increase of height or due to this difference in the piston level, so how much load is going to lifted by this, that need to be calculated. Okay, so this is also similar way, but one more thing will be added on this. Okay, the pressure intensity first at same level na different pressure intensity is there, again some more height is there, means again one more pressure intensity is going to add on that. So for this condition for B, okay, we can write the let consider a section here, that is A. So we can write the pressure intensity at section AA equal to, okay, what is the pressure already there at the same level, that is nothing but F by A plus the pressure intensity due to this increment of this height 40 centimeter. So that one we can calculate by the formula rho g h. Okay, that is actually the formula which came from the hydrostatic law. Okay, now this Fa already we got here previously, Fa, so that Fa plus rho gh, rho already given 1000. So already what we can do, F by A equal to, we can calculate here, let 80 divided by 7. So how much, 11.42 plus 1000 into 9.81 into this is 40. This is 40 centimeter. So this is the pressure intensity, okay, at A point we can say. Now this is about the pressure intensity at the due to this height, how much is there. Now what we need to calculate, we need to find out what is the load lifted by the large piston. That means due to this impact, how much load is going to lifted here. Okay, initially at the same level, now there is a distance is there, there is a gap is there. That means some height was increased here, and due to this height increased, so how much load is going to lift by this in this side, you can say. Okay, so that means we can calculate that force. Okay, the force or the weight lifted, the weight lifted equal to, we can write what is the pressure and area. The pressure area, because force we know that the pressure into the area. So pressure we got already here, this value, total value. So that will be near about, we can multiply this 1000 into 9.81 into 40 plus 11.12. So 3,92,004 something is there, 411. Okay, this is the pressure intensity Newton per centimeter square is there. Okay, so this one multiply with the area. Okay, so that will be give you the force or the load lifted by this impact of this. So that one we can also write here. Let me write here. So the force is going to lifted by this. So how much pressure intensity is there? 392,411 into the area of this. Area equal to how much here? 78 meter square, centimeter square, not meter square, centimeter square. So by that we can find out the total how much is there. Okay, so I hope you understood how to solve like this, and if any changes are there, that means unit changes, you can do it that one. So that is not a huge problem on that. I hope you understood how to solve the problem related to Pascal's law. If you are having any doubt, you can give a comment on the comment box. Thank you all.